So, if this strand is cat, gag, cac, when it's copied, the new nucleotides coming in have to complement that letter. So that after copying, the strands are complementary. Okay? So what would the complementary strand be? Good. G, T, A, C, T, C, G, T, G. Right? Did I get it right? Every once in a while I make a boo-boo. That would be the complementary strand. Good. What the heck do all these letters code for? They code for amino acids. Some of them code for start. It's the start of a gene. Some of them code for stop. It's the end of a gene. The rest of the letters are the recipe for building a protein. And what do proteins consist of? Amino acids. So the codons, if it's not a start or stop codon, it's a codon for an amino acid. Now, since we're just looking at DNA replication, we're just looking at a portion of the DNA, we don't really have to worry about the start and the stop so much. That comes in handy when you're replicating just one gene at a time for protein synthesis. But here, theoretically, we're replicating the entire DNA, so we're not going to worry about that. But we are going to look at, here's one codon. The codon is 3 letters. Technically, this side would also be called a codon, but actually, it's the same thing. This is just a mirror image of that for inheritance purposes. When it comes to protein synthesis, you're only going to look at one strand. You're not going to have to copy both strands. So a codon. And what is a codon? It's 3 letters. What are the letters? They're nitrogen-containing bases, or I call them nitrogenous bases of the nucleotides. What is a codon? It's the genetic instruction or the word for an amino acid. And I'll just put or start or stop. But that doesn't actually come up in DNA replication so much. Protein synthesis. Codon is 3 letters long. C-A-T, G-T-A, whatever. Codon's 3 letters long. It's the word for an amino acid. So usually on your test I have a question that goes something like this. Now remember, it's not your second test this weekend, it's your 3rd test next weekend. What's the most important part of the DNA? You think it's the sugar or the phosphate? No, it's the letters. The letters are your genetic code. That's your genetic code. When they say in the Human Genome Project, anybody heard of the Human Genome Project? Well, by your standards a long time ago, by my standards yesterday. The Human Genome Project sequenced the genome. So when they talk about sequencing the DNA, we're talking about what are the letters? What are the letters spelling out? What amino acids are we talking about? What protein does that make? Okay? All right. Let's do something else over. Here goes the analogy. I thought it was mine for like 20 years, and then all of a sudden I heard everybody else using the same analogy, and I'm like, I should have put a patent on that, copyrighted it, that's the word. Here's the cell's genome. Is all its DNA. It's nucleoid genes, and if it has a plasmid, they count too as part of the genome. So the genome is the cell's entire DNA. So let's think of where they came from. Where do you get your genes from? Your parents. Your mom and your dad. And where did they get their genes from? Their parents. and they got their genes from their parents. So with every generation, you get some random handful of your father's and your mother's genes, which may include genes from their parents and their grandparents and their great-great-grandparents. So it's really your entire genetic history. So we're going to call the genome the family cookbook, kind of like the family album. You know, remember the family albums they used to have in the olden days? Every once in a while on Antiques Roadshow, they'll bring one out. When my grandma passed away, she had a family album in her possession. And it was a big old book where they wrote, you know, what the hell were their names? Cora married, I remember my great-great-grandpa's name. Anyway, who married who, and it was all handwritten because they didn't have computers on. So, but we're going to call this the family cookbook. Yeah, like a family tree, right. Well, we also did have some recipes that my great-grandma had written in her hand, like, you know, with a pinch of salt and a dash of vanilla and that kind of lingo and a cup of lard. And she kept on the stove. When I was in high school, I drove with my grandma up to the farm. And at the farm, which was going to be sold because my great-grandma had passed away, there's this old house, you know, and they climbed up a ladder into the loft, and that's where the kids slept, up in the loft. And on the kitchen stove, she had this big old jar of fat. So whenever they cooked meat or chicken and the fat came off, they saved that fat in this jar. And then when she was making pie crust, that's what she used to make the pie crust. And I want to tell you, that's the best pie crust ever. It melts in your mouth. It's so good. But anyway, so your genome is your family cookbook. And in your family cookbook, you have a bunch of recipes. I have a recipe for blue eyes, and believe it or not, what used to be brown hair, fat thighs. I got that from my grandma. So each recipe is a gene. So we'll just put gene, we'll go singular, how about that? A gene is a recipe. Your recipe is written in words. Oops, word goes over here. And the word is a codon. And a codon contains letters, right? A word is made up of letters. And what are the letters? A, C, T, and G. They're nucleotide bases, nitrogenous bases or nucleotide bases, whatever you want to call them. Nitrogenous, nucleotide bases, whatever you want to call them. Bases. Sometimes on your test it'll have the word bases, and then next to it I'll have in little quotes letters, so you'll remember it's the letters. So the nitrogenous bases, by that we mean A, C, T, and G for DNA, because we're talking DNA right now. Right? Okay, everybody's okay with that? Good. You're okay with DNA replication? Good. Because now it's going to get a little hairy. We're going to do protein synthesis. Huh?
This is a freaking
Since you didn't have me to make it kindergarten level. But I would rather you got the gist of it kindergarten level than throw a million details at you that are going to confuse you, you're never going to remember, and you don't need. I want you to have a general idea of DNA replication and protein synthesis, because we have to talk about viruses. You're not going to understand how viruses replicate if you can't understand this. Yes, Colton?
You gotta switch that. Template's on the other side, not that.
Thank you.
This is like the original one.
The original one is
the
called
code
what?
form, and the other one is we're using the template of it. I always just mix them back and forth. It makes more sense if that's the template.
You want me to call this one the template strand?
Right.
And that's the one they make proteins off?
Yeah. Well, no. Don't make proteins off your coding strand.
Yes. Okay.
That's
Thank you. So a lot of terminology has changed, and in your textbook I noticed they use new terminology, and some of it's not quite what we had in our old textbook, so. Okay, what Colton is explaining will affect us when we get into protein synthesis. Your more original strand, which in the olden days we called the sense strand, is the coding strand. That's your genetic code. This template strand is the complementary strand, the copied strand, okay? But it also carries the code. In the olden days, we called that the antisense strand. And actually, sometimes when I look at the figures in your textbook, I'm not sure if they made a mistake on something or if I'm interpreting it wrong. So, but anyway, complementary strand, template strand. This is the copy, the copied strand, the copy of the original. Okay. In the olden days, did I tell you about Dr. Russell? I probably did, but I'm going to tell you again anyway. So when I was in college, God, I was cute. Of course, you don't know it at the time. Now I think back, I was like, yeah, I was cute. But anyway, so I must have been like 19 years old or so. And I had Dr. Russell for genetics. And you gotta remember, this was a lot of years ago. We're talking like 1977, 78. And people were just beginning to understand